In 2011, NASA's Swift satellite caught an X-ray outburst from a small galaxy 3.8 billion light-years away. Within a couple of days, researchers realized they were witnessing the aftermath of a tidal disruption event, a star ripped apart by the monster black hole at the galaxy's center. Some of the stellar material fell toward the black hole, forming an accretion disk and a jet pointed in our direction.
Tidal disruption events offer us this rare view at the most common kind of supermassive black hole in the universe, these so-called dormant supermassive black holes. 90% of black holes in the universe don't have a lot of hot material orbiting around them. They don't form these accretion disks, and so we can't observe them. Tidal disruption events, where the stellar debris causes the formation of a temporary accretion disk, offers us a way to probe this population of supermassive black holes.
Swift monitored the outburst's progress and was joined by the European Space Agency's XMM-Newton observatory and the Japanese Suzaku satellite. Recently, astronomers introduced a new analysis technique that for the first time allows them to peer deep into the gravitational well of a normally quiescent black hole. Called X-ray reverberation mapping, the method charts the region close to the black hole using light echoes from X-ray flashes, similar to the way sonar uses sound to map the ocean floor.
X-ray reverberation mapping has been very successful at probing the accretion flow in well-established accretion disk structures, but had never been used to look at tidal disruption events. My collaborator at the University of Maryland and I were having lunch one day, and she says, "Has anyone ever looked at tidal disruption events with X-ray reverberation mapping?" That night, I stayed late at the office and just tried it out on this data from Swift J1644, and much to my surprise, the result was amazing, and I could see that we were looking at the structure of the inner accretion flow around a normally dormant black hole for the first time. It's not like a normal accretion flow in an active galaxy that's a flat disk. This is something that is extremely puffy, very turbulent, and we are measuring flashes of X-ray emission deep within this newly formed accretion disk.
Stellar material streamed into the developing disk, churning it into a thick, chaotic whirlpool of X-ray emitting gas, funneling toward the central black hole. Deep inside this cavity, multiple X-ray flares erupted, providing a flash that echoed throughout the region.
Previously, astronomers had thought that the X-ray emission is coming from far out in a jet. But what we're finding with these observations is that the X-ray emission is coming from flares very close to the supermassive black hole. And we can use these observations to probe properties of the black hole itself. For instance, we found that the mass of the black hole is something on the order of 1,000,000 times the mass of the Sun.
The first observations of X-ray reverberations from deep inside an accretion disk are providing new insights into a rarely observed class of black holes. They're also laying the groundwork for a better understanding of tidal disruption events and the black holes they illuminate.